All right, removing digits from the CSES problem set. Again, this is a dynamic programming question. So we have a number n and we just remove digits from that number. So every time, for example, if we have 27, we can remove 7. Then from the resulting number, which is 20, we can remove the digit with number 2, then we get 18. From this, we can remove 8, then we get 10. From 10 we can remove digit with number 1, then we get number 9, and then we remove 9 from itself and we get 0. Okay, so this problem has two solutions. The first one is the greedy one, that is we always subtract the greatest digit. Why this works, I have no idea. I didn't sit down to prove this. I just tried and I saw that it works. Like the proof for this, like of course there should be some mathematical proof for this, but like during a contest, if you want to play it safe, rather than spending time proving that this is true, you could just write the dynamic programming solution. So let's first of all look at the greedy solution, how to implement it. So you just read the number. The solution is 0 steps initially, and while our number is greater than 0, thus we have still digits to subtract essentially. We are going to find the biggest digit each time. So we just save our number into a temporary variable. As long as this temporary variable is greater than 0, we just pick the last digit by doing modulo 10. So 10 modulo 10 would give us the last digit. And if this digit is greater than the biggest digit we found so far, which initially is equal to 0, then the biggest digit is that number. And then by dividing by 10, we're essentially deleting that last digit, and we shift our number to the right essentially by deleting that digit. And after we find the biggest digit that our current representation has, we increment the solution by 1, so one more step, and we decrease our number by the value of that digit. And we repeat this until our number is 0 essentially. And then we output the solution. And that's pretty much it. That's the greedy solution. And what's the dynamic programming solution? The dynamic programming solution is you have an array of 1 million? Yeah, 1,000,001 places. So from 0 up until 1 million, because n can only be up to 1 million, including 1 million. And then what we do here is we just initialize every solution to be equal to, here I just put 10 million to showcase that it is impossible. So far it is impossible to reach that number, right? And then we go from n, which is the initial number, up until 0. And we're going to decrement since we're going downwards. And we're going to check if this number is reachable. So far, if we can reach it, then the dp for that number is going to have some value that is not 10 million. Here I just put 10 million to showcase that there is no solution. And what do we do in that case? We take the number, so into a temporary variable, we save I, and then while our number is not equal to 0, we are going to get the last digit again with this technique, modulo 10. And the solution to our dp can be reused for the solution for dpi minus the digit. So if we remove that digit, then the solution for dpi minus the digit will be equal to either the current solution that we have for our digit plus 1, since we are removing one more digit, or it's going to stay the same as it is. So we use the minimum function to pick the minimal solution. Otherwise, actually, if there is no solution for this subproblem, it's going to be 10 million. So our solution will always be smaller than 10 million, right? For apparent reasons. And then we divide this temporary value by 10. That's, again, deleting the last digit. And we go through all the possible digits that we have in the current value of the number. And thus we cover all the subproblems that are below the problem we have right now. And then we output dp0, which is what we want. We want to reach 0 essentially with our number, and that's the solution. So again, in problems like this, instead of proving that the greedy solution is true, sometimes the greedy solution, most of the time, why would you use dynamic programming is because the greedy solution doesn't work. In this case, it works, but proving that it works will take time in a contest. So it won't take much more effort to just implement the dynamic programming solution rather than the grid solution in this case. So we implement the dynamic programming solution, and we get accepted. And that's pretty much it. What the takeaway from this problem is, of course, the greedy solution, knowing that the best strategy for reaching 0 when you subtract only one digit from a number every time is by choosing the greatest digit. So keep that in mind, and you might reuse this information in future problems. If you like the video and it helps you solve the problem, leave a like, subscribe to the channel, and I will see you in the next video.